Hi everyone, this is topic 5.2 Introduction to Rate Law, and this is taken from AP Chemistry College Board. In this topic, I'll be talking about what is a rate law and what it all includes and what are the things we need to keep in mind whenever we are writing the rate law for or the rate equation for any reaction, and what are the things which are involved in that whole rate law. So let's start. The rate law is the one which shows the relationship between the rate of a reaction, as you can see here small r, to the rate constant, which is written as small k, and the concentrations of the reactants raised to some powers. Now here let's consider an equation where capital A plus capital B is giving capital C and capital D. So these A and B are the reactants where the coefficients of these reactants are small a and small b. Now, whenever we are writing a rate equation or the rate law, we need to write first of all the rate of the reaction, that is small r, is equal to small k, and that is what is called the rate constant, times concentration of A raised to the power x. Now this x is basically called the order with respect to A, and multiplied by concentration of B raised to the power y, and this y is the order with respect to B. And these are not the coefficients of A and B. These are some other numbers which are determined experimentally. I'll be showing you some examples where I'll tell you that how can we actually determine these orders. Now the next thing is small r is the rate. This thing I have already told you, small k is the rate constant, and this rate constant is temperature dependent. It doesn't depend on the rate of the reaction. It doesn't depend on the concentrations of the reactants, but it only depends on the temperature of the reaction at which it's happening. So this whole equation is called the rate law or rate equation. I already told you that order is what we get from experiments. So the rate law are always determined experimentally. It is not a theoretical equation. We have to find the orders by doing the experiment. Then reaction order is always defined in terms of reactant concentrations. We always write it for the reactants and not for the products. The order of the reactant is not related to the stoichiometric coefficient of the reactant in the balanced chemical equation. Now let's consider this equation where F2, that is fluorine, is reacting with ClO2 and giving FClO2. Now after balancing this equation, we get these coefficients of reactant and product. Now when we are writing the rate law for this chemical equation, we will write it as rate is equal to small k times the reactant concentrations raised to the power their orders. Now when we are writing this, the reactants, it will be F2 concentration and ClO2 concentration. But here you can see the difference that we are not writing the coefficient as the power, but we are writing what we get experimentally. It is not the stoichiometric coefficient, but it is the order which we got by doing the experiment. So that's why here, although it is 2 ClO2 after balancing, but still here it is 1. Now let's see the same equation and let's see that how did we get ClO2 raised to the power 1 in the rate law. Now here F2 is reacting with ClO2 and giving FClO2. Now this is the table which will be given in the question, that how you are changing the concentrations of the reactants and how the initial rate of the reaction is changing. And you are asked to find out the rate orders of these reactants, that is F2 raised to power the x, ClO2 raised to power y, and you have to find x and y in this rate law. So let's start that how can we actually determine these two quantities. Now, first of all, you need to see the two experiments in which the one of the parameter is kept same and another parameter is changed. That is, we need to actually focus on these concentrations. So when we see the first and second experiment here, can see that the fluorine concentrations is kept constant, but the ClO2 concentration is varied. That is, it has become 4 times in the second experiment. Now let's compare the initial rates here, that when the concentrations were 0.1 and 0.01, the rate was 1.2 multiplied by 10 to the power minus 3 molar per second. But when we have made the ClO2 concentration 4 times, the initial rate has also become 4 times. Now what does that mean? This means that the rate is basically dependent on ClO2 as the same type. It means that the order with respect to ClO2 is 1. Now let's compare the other experiments, where experiment 1 and 3, where the concentrations of ClO2 are kept constant, that is same, that is 0.010, and the F2 concentration is basically doubled. So as you can see here that it is 0.10 and here 0.20. Now let's compare the initial rates of experiment 1 and 3. Now you can see here that in experiment 1 it was 1.2 multiplied by 10 to the power minus 3, and in experiment 3 it is 2.4 multiplied by 10 to the power minus 3. Now when we compare these rates of first and third experiment, we can get to know that for the third experiment the rate has also become doubled. So when we are doubling the concentration of F2, the rate is also doubled. This shows that the rate is also in first order with concentration of F2. So that is why the final rate law will be rate is equal to small k, that is rate constant. We need to write it like this only. Concentration of F2 raised to the power 1. Why 1? Because I told you that as we have doubled the concentration of F2, the rate has also doubled. So that's why it has become 1. And ClO2 raised to power 1. Why? Because when we have made ClO2 concentration 4 times, the rate has also become 4 times. So it is directly proportional to these quantities, and this is the final rate law. Now let's see another question where you have to determine the rate law and calculate the rate constant for the following reaction from the following data. So a reaction is given and the data is given in the form of table again, and you have to first find out the rate law, and after finding the rate law you have to find the rate constant. So let's see how can we do these type of questions. So the reactants are S2O8 negative and I negative. So these concentrations are given here, their values are given, and the initial rates are given. Now first thing I told you is to compare the two experiments in which one of the concentration is kept constant and the another one is changed, and that's how you can compare the rates of those two experiments. So when we see these three experiments, you can see that experiment 1 and 2, the S2O8 negative concentration is kept same, that is 0.08, but the I negative is 0.034, and in the second experiment it is 0.017. So this shows that the I negative concentration has basically halved here. Now if the I negative concentration is halved, let's compare the initial rates of these first and second experiment. You can see here that it was 2.2 into 10 to the power minus 4 in the first experiment, and in the second experiment it has become 1.1 multiplied by 10 to the power minus 4. So here also it has become half. So it means that the rate law will be first order with respect to I negative. Now let's see for S2O8 negative that we need to compare the experiments where I negative is kept same and S2O8 negative concentrations are changed. So here when we compare these data, you can see that experiment 2 and 3 are the correct experiments to compare to find out that how it is changing with respect to S2O8 2 negative. Now I negative concentration is kept same, but the S2O8 2 negative concentration has been doubled in the third experiment, and the initial rate has also become doubled. So this means that this reaction is also first order with respect to S2O8 2 negative. So the final rate law will be rate is equal to K multiplied by concentration of S2O8 2 negative raised to the power 1, I negative raised to the power 1. So this is the final rate law of this equation. Now the second part of this question was to calculate the rate constant. Now you can consider any of these experiments to find out the rate constant of this experiment. Now you have the rate in this table, you have the concentrations in this table, and you can find the K from these all values. So we have taken the first experiment here. K will be equal to rate upon S2O8 2 negative multiplied by I negative concentrations. So we'll just put in the values of the first experiment. You can take any of these experiments. Just make sure that all the three quantities should be from the same experiment. So we'll put these values in here, and the final answer is 0.08 molar second. So this is how you can actually calculate the rate constant and rate law for any data given. But before calculating the rate constant, you should be knowing the rate law so that you can actually put in the values in this equation and find the rate constant. Sometimes the rate law is given directly to you and you have to only calculate the rate constant from the values given. I hope this topic is clear to you. I have given you two examples that how can we actually find the rate law and calculate the rate constant also. If you like this video, please subscribe to my channel Log Iota and press the bell icon.